Hello and once again welcome everybody, and today we are going to continue with our A level mathematics. Okay, and I think we were into that series I was making on modulus functions. Okay, modulus functions, right? And in this I have already covered some 2-3 videos. Perhaps this must be the fourth one, I don't remember exactly. But in this today's video we are going to learn how to quickly plot the graphs of certain modulus functions. Okay, not the simple ones but little complicated ones, or you can say the modulus functions which are of the composite form, right? So let us start with now on the right hand side. You can see I have selected some 7 to 8 functions. Can you see here? This is 1, 2, 3, 4, 5, 6, 7, 8, right? So all this, one by one, I'm going to tell you how to plot them, okay, or how to rather draw the graphs of these functions, okay. Now, some of the concepts, some of the tricks that we are going to use in, uh, uh, making these graphs, okay, of these modulus functions. So those tricks, you have to remember by the end of this session. There will be a couple of tricks or more than that, okay, which you should always remember, right? So that those tricks, I'm going to summarize in the end of the video, okay. So let us start with the very first one, and the very first one is this one: y is equal to modulus of x plus 7. Can you see this? Y is equal to modulus of x plus 7. Okay, now actually this is the answer for it. This is the graph of y is equal to modulus of x plus 7, but I will explain you how you got this shape, okay. So y is equal to modulus of x plus 7, right? Okay. So obviously the vertex will be at minus 7 comma 0. Okay. Vertex will be at minus 7 comma 0. And this is in general form. You can write this as y is equal to x minus h plus k. If this is the general form, your vertex will be at h comma k. Okay. So going by this general form, if it is modulus of x plus 7 plus a 0 over here, assume there's a 0 over here. So vertex will be minus 7 comma 0. So that is the vertex. So your graph will be V shape at minus 7 comma 0. It will be V shape, right? Now you can see that this graph is intersecting the y-axis somewhere. Okay. So what will be this particular y-intercept? For that, you will have to do one thing. You will have to put x equal to 0. So when x equal to 0, your y will be equal to modulus of 7. That's it, which is equal to 7. So when x is equal to 0, your y is equal to 7. So this will be 7. Now can you see this? The y-intercept is 7 over here, and the vertex is at minus 7. So this is the graph of this. Okay. So that was the first one. Now let us go to the second one. Okay. Now the second function is y is equal to modulus of 3x minus 6. Okay. So this is that second function. Y is equal to modulus of 3x minus 6. 3x minus 6. Now you can always factorize this as y is equal to 3 modulus of x minus 2. Okay. Now, if you want to plot this graph, again, this is x minus 2. Okay. So take x axis and y axis. Okay. Now this being x minus 2, the vertex will be at 2 comma 0. So here there will be a vertex. So draw a V shape over here. Now this 3, don't worry about this 3. This is not going to change the shape of the graph, but it is going to slightly compress the graph. Okay. So this particular y-intercept will be when x is equal to 0. This should be 3 and modulus of minus 2, which is nothing but 3 into 2, which is 6. So this point will be 6. Okay. And this V shape, it will be slightly compressed because of this 3. Okay, so can you see this V shape is slightly compressed? Okay, but the vertex is at 2. You can see here 2, and the Y intercept is 6. Can you see? It's 6. So this is the answer for the second one. Okay, now let us go to the third one. Okay, so whatever concepts I'm using here, I think we have discussed this in the earlier class, okay, earlier video, and the vertex form and all that, so that I'm using here, but directly without much explanation, I'm just constructing the graphs. This is the third one. Y is equal to modulus of 2 minus x. Y is equal to modulus of 2 minus x. Now here one concept you should recollect at this point, that modulus of a minus b, okay, is the same as modulus of b minus a. A very important concept. Modulus of a minus b is equal to modulus of b minus a. So going by this law, or you can say by this axiom, modulus of 2 minus x can always be written as modulus of x minus 2. So if you want to draw the graph of modulus of 2 minus x, it is as good as drawing the graph of modulus of x minus 2. So this I will take it as modulus of x minus 2. Now this graph I know how to draw. I'll take x and y axis. Now here the vertex will be at 2, 0. So here the vertex is 2, 0, and our V shape. Okay. And this particular point, the y-intercept will be when x is equal to 0. So when x is equal to 0, y will be modulus of minus 2 plus 0. So y will be 2 plus 0, which is 2. So this will be 2. So the graph will be this. Okay. So can you see the third question? The graph is V shape, and the vertex is at 2, and the y-intercept is 2. Okay. So important concept, this. Remember this. Okay. Done? Okay. Now let us go for the next one. The next question is the fourth one. Okay. So, okay, I'll do one thing. I'll write the important concepts over here. So, first concept is the vertex form that we keep on using. Second concept is modulus of x minus 2, or rather modulus of a minus b. Let me write modulus of x minus k is equal to modulus of k minus x. Okay. Now, so that was the third question. Let us go to the fourth one. And the fourth one is this. Y is equal to modulus of 5 minus 8x. Okay. 5 minus 8x. Okay. Here again, I am going to use this same rule. X modulus of x minus k is equal to modulus of k minus x. So here I am going to use the same concept, and I am going to make it modulus of 8x minus 5. Got it? Now, because x has a coefficient, now I'll have to factorize it. So I'll take x out, and it will be x minus 5 upon 8. Isn't it? Y is equal to 8 modulus of x minus 5 upon 8. Okay. Now I will proceed with the graph. So the vertex will be, it will be at 5 by 8, 0. There's a 0 over here. Okay. So let that 5, 8 be over here. Okay. So this is the point where the vertex will be there, and it will be V shape. This point has to be when x is equal to 0. So when x is equal to 0, the y will be equal to 8 times. Now I'm putting x over here 0. So y will be equal to 8 into 0, 0 minus 5. So it will be y will be equal to modulus of minus 5, which is equal to 5. So this point has to be 5. That clear? You can use even here. Okay. So when x is equal to 0, y will be equal to 8 times Okay, x is 0, so modulus of minus 5 by 8. This will be 8 multiplied by minus 5 by 8, modulus will be 5 by 8. 8 cuts away, so you get 5 still. Okay, so whether you do this way or this way, you're going to get this as 5. So can you check the answer for fifth one? Yeah, this is the fifth one. Can you see that? This is the fourth one, not fifth one. Okay, so this is that answer. Can you see the vertex is at 5 by 8? Vertex at 5 by 8. Okay, and your y-intercept is at 5. You see the y-intercept here is 5. Okay, so that was the fourth one. Now let us try and do the fifth one. Okay, so fifth is this one, right? Y is equal to modulus of x plus 2. So let me do that now. Y is equal to modulus of x plus 2. Now here again there are two approaches, and I'll explain you both the approaches. Okay, so by both the approaches you are going to get the same answer. So y is equal to, this is the fifth one we are doing, right? Y is equal to modulus of x plus a 2. So this is y is equal to f of x plus 2. Okay, so you know f of x is modulus of x. So first let us draw that graph. So modulus of x will be this. This is modulus of x. And then plus 2. This plus 2 indicates that the whole graph of f of x is going to be lifted up by 2 units. So it will go here. So this is the graph of modulus of x plus 2. Okay, this is my transformation of graph that I have used. Okay, but there's another way of doing it. Suppose you have y is equal to modulus of x plus 2. So let us go by the vertex form. So this is modulus of x minus 0 plus a 2. So the vertex will be at 0 comma 2, right? So you take this x and y coordinate, and 0 comma 2 will be somewhere over here. Okay, so you will get a V-shaped graph at 0 comma 2. So either you do this way or you do this way. These are the right answers. Okay, so can you see the fifth one? This is the graph. Okay, V shape at 2 comma 0, 0 comma 2. Okay, this is 2 V shape graph. Can you see? Either this one or take this one. Okay, this is the vertex form of approach, and this is the transformation of a function approach. Now let us move on to the sixth one. Okay, graph number 6. See how if you know the concept, okay, if you have understood the logic, it's so easy. You should not struggle with the graph. Like, you should not get confused, like what to do and what not to do. So let us move on to next one, that is sixth. So this is that sixth one. It is y is equal to modulus of x plus 5 minus 3. Y is equal to modulus of x plus 5 minus 3. Now this is clearly a function where vertex form can be used. So vertex of this graph will be at minus 5 comma minus 3. Okay, so very nicely I will first see where is minus 5 minus 3. This is minus 5, this is say minus 3. So this is the point where the vertex will be minus 5 minus 3, right? Okay, now here at this vertex I should have a V-shaped graph. But then let me first decide what will be the y coordinate, or y-intercept rather. So to find the y-intercept, I'll put x equal to 0. So when x is equal to 0, my y will be equal to modulus of 5 minus 3, which is equal to 5 minus 3, which is equal to 2. So that should be a y-intercept at 2. So this V-shaped graph should be something like this. Okay, but now Apart from this y-intercept, I am supposed to find out this x-intercepts as well. Okay. What is this? What is this? Okay. I cannot leave it unlabeled. Right. Now to get the x-intercepts, what I'll do, I'll put y equal to 0. In this equation, I'll put y equal to 0. So 0 will be equal to modulus of x plus 5 minus 3. If I rearrange, it will be 3 equal to modulus of x plus 5. And third concept, let me write here. If modulus of x plus k is equal to something, say delta, the meaning of this is, this implies that x plus k is equal to delta and x plus k is equal to minus delta. This is the meaning. Okay. So this concept I'm going to use here. So modulus of x plus 5 is equal to 3 implies that x plus 5 is equal to 3 and x plus 5 is equal to minus 3. If you rearrange this, x will be equal to 3 minus 5 minus 2, and here x will be equal to minus 3 minus 5, so minus 3. So you are getting the values of x, minus 2 and minus 8. So this can be your minus 2, okay, and this is your minus 8. Okay, these points. So this is the shape of the graph. Now, can you see this? Question number 6, the answer is this. Only thing is, this points, I have not marked, so I will mark it right now. So these 2 points, these are the roots of the equation, right? This is minus 2, and this one is minus 8. Right? Yeah, minus 8. Okay, minus 2 and minus 8, right? And the midpoint of this minus 2 and minus 8 has to be minus 5. Okay. So because of symmetry also, suppose you have a minus 5 over here. This is at minus 5. Okay. So by symmetry, suppose this is minus 2. So this is 3 distance apart. Okay. So here also you'll have to go 3 distance apart. This is 3. So this will be also 3, minus 3. So minus 5 and then minus 3 will be minus 8. So this way, by symmetry also, you can get the answer as, the x-intercepts you can get as minus 2 and minus 8. Or you can solve the equation and get minus 2 and minus 8. Okay. So there are many approaches and many ways. So just remember the concepts. Okay. The concepts that you are learning, how we are using here, that application of the concepts, you pay attention over there, because this is how ultimately you have to solve your mathematical problems in higher levels. Okay, so you should understand the concepts, you should know the concepts very well, and you should logically apply the concepts in those complicated problems. Okay, so you should be confident enough to use those concepts. Okay, anyways, that was question number 6. And the last one, no, not last, the 7th one is this one. Y is equal to 8 minus modulus of x plus 10. Okay. Now here you have to be a little careful. Okay. This in the quadratic, suppose you have y is equal to, say, something, say 8 only, and then instead of this modulus function you have x plus h the whole square, and then plus a k. Okay, now plus k is over here. Okay, nothing will be there, so it will be like that. Okay, now this is for quadratic, this is for modulus. Here the vertex, in this case the vertex will be at minus h comma k. Now what is the k in this case? The k in this case will be this can be rewritten as minus of x plus h the whole square plus 8, isn't it? So your k is nothing but 8. Okay, so the vertex will be minus h comma k. Okay, so suppose here it was 8. So your k will be 8. Okay, minus h comma 8. This will be the vertex. Same logic if you apply over here. Here the vertex will be this is x plus 10. Okay, so it will be okay. Now this, you know, here what I will do is it is vertex will be at minus 10 comma your k will be 8. Okay, so your vertex will be at minus 10 comma 8. So let us take the x and y axis. Okay, minus 10 comma 8 should be somewhere over here, minus 10 and 8 over here. Okay, so the vertex will be minus 10 comma 8. Now at this point the graph is not going to be V shaped. Okay, remember that it will be inverted V. Why? Because can you see here this x minus h the whole square bracket, before that bracket you can see a minus. Okay, here also x plus 10, modulus of x plus 10, before that you see a minus. Okay, so if it is x plus h the whole square, if it was plus over here, then it would have been a parabola. Okay, but because it is a minus, it will be an inverted parabola. Same way here, because it is a minus before a modulus function, that V shape will be inverted. So the V shape will be something like this. Okay, then again you will have to decide what is this y-intercept and what are the x-intercepts over here. So first let us find out what is the y-intercept. So shape of the graph will be something like this. Now let us find out these three things. Okay, so first the y-intercept. So for y-intercept you will have to take x equal to 0. So your y will be equal to 8 minus modulus of x is 0. It will be plus 2. So this will be 8 minus 10, which is minus 2. So okay, I have drawn the graph slightly wrong. It should pass through this. Okay, so let me correct it. So my V shape, inverted V, will be something like this, passing through minus 2. Okay, and now you are supposed to find out these two x-intercepts. So to find out the x-intercept, there are two approaches. Now this is minus 10. Okay, and you don't know what is this and this. Okay, so both you don't know. So okay, so we are going to use the method of solving the equation. So 0 will be equal to 8 minus modulus of x plus 10. So if you take this modulus of x plus 10 on the left hand side, it will be equal to 8. Now this has two meaning, x plus 10 equal to 8 and x plus 10 equal to minus 8. Okay, so this will be either x equal to 8 minus 10, that is minus 2. Okay, x equal to minus 2, or this will mean that x is equal to minus 8 minus 10, so x equal to minus 18. So your answers for x will be either 2 or minus 18. So this x-intercept will be 2 and minus 18. Okay, so is it 2 or minus 2? 8 minus 10 is minus 2. Okay, this will be x equal to 8 minus 10 minus 2. Okay, so this is going to be a minus 2 and this is going to be a minus 18. Okay, so now you can compare this with this answer. Okay, so can you see the y-intercept is minus 2? Okay, and this x-intercepts will be, this will be minus 2 and this will be minus 18. Okay, I hope you understood, right? And the last one, that is number 8. Okay, let us do that also. So that is similar to this 7th one. So let us do that and complete today's video. Okay, so okay, 8th one. Right? Question number 8. Y is equal to this one. Y is equal to 15 minus modulus of 3 minus 5x. Okay. Now we have so many things we'll have to do concept wise. First, this 3 minus 5x, I'll have to make it 5x minus 3. So I've used this concept. X minus modulus of x minus k is same as modulus of k minus x. So modulus of 3 minus 5x is same as modulus of 5x minus 3, right? Second concept, I will factorize it. So 5 I will remove out. So it will be minus 5 x minus 3 by 5. Am I right? 15 minus this 5 is coming out. It will be x minus 4. Now I can see that this is of the form where the vertex can be decided. So my vertex will be equal to, vertex will be at minus 3 by 5. Okay, minus 3 by 5 and minus 3 by 5 and plus 15. This will be the vertex. So let us proceed with the graph. The graph will be, vertex will be at minus 3 by 5. So suppose this is minus 3 by 5 and 15 on the y-axis. So suppose this is 15, right? So this is that point. This will be my vertex. Okay. Now, can you see this modulus function, okay, is having a negative sign in front of it. So it will be an inverted V, not a straight V. It will be inverted V. Moreover, you have 5 in front of it. So it will be slightly compressed. Okay. So it will be inverted V and it will be compressed also. And at the same time, we'll have to check what will be the y-intercept and the x-intercept. Okay. So roughly, let me draw it this way. Okay. If there is any changes, we will redraw it. Okay. So we got the vertex over here. This is minus 3 by 5 comma 15. And now let us find out this point, that is the y-intercept. For y-intercept, what I will do is I will take y equal to 0. So in that case, what will happen? 0 will be equal to 15 minus modulus of 3 minus 5x. So if I write it this way, 3 minus 5x, modulus of 3 minus 5x equal to 15. And if this I write as 5x minus 3, because I can always do that, equal to 15. Okay. Now, if I take 5 common out, this will be 5 modulus of x minus 3 by 5 equal to 15. Now, if this 15 I bring over here, so this 5 if I bring over here, this will make it x minus 3 by 5 modulus equal to 3. Now, the meaning of this is x minus 3/5 equal to 3 and x minus 3/5 equal to minus 3. This concept. Okay. From here, I'll get the x value as x equal to 3 plus 3/5, which is equal to 15 plus 3, 18/5. Okay. And from here, I'll get x equal to minus 3 plus 3/5. That will give me 5 3s are 15 minus 15 plus 3 is minus 12/5. So I'm getting the 2x intercept as minus 12/5 and 18 upon 5. Okay. So this will be 18 upon 5. Okay. This should be my 18 upon 5. And this should be my minus 12 upon 5. Okay. And this y-intercept, I told you, how much was the y-intercept? When y is equal to 0, what was the y-intercept? It was 12. Okay, so this will be 12. Okay. So can you check this 8th one? The y-intercept is 12 over here. Can you see? And this will be my negative side. May you have minus 12 by 5. And here on the positive side, I'll have 18 upon 5. Okay. So this is the final graph, and vertex you can see it is at 3 by 5 comma 12. 3 by 5 No, this should be, I think this graph is not correct, right? It is x minus 3 by 5, right? 5x minus 3, 5x minus 3 by 5. Okay. See, this because this is minus, the vertex will be at plus 3 by 5. Okay. So this was wrong. This vertex was wrong. It should be on this side, 3 by 5. Okay. And from here, you should have the graph. So let me redo this. Okay. So there was a slight mistake here. First of all, let me draw, let me see where the vertex will be. It will not be this minus 3 by 5. It will be 3 by 5 comma 15. Okay. Because there's a minus over here. So this will be the vertex 3 by 5 and 15. This 12 is also wrong. It should be 3 by 5, 15. Okay. So vertex will be here 3 by 5 comma 15, and it will cross through, this is 15, this is 3 by 5, and the V-shaped graph is going to be like this. Okay, so this is going to be my y-intercept, which I got as 12, and these two, okay, these two will be my minus 12 fifth, and this will be 18 fifth. Okay, so this is the graph that you get. Now it is correct. Okay, so I hope you must have understood. It was a slight messy type of a video because I have done everything on one page only. But then if you do it independently, separately, then I won't be able to explain you properly. And that is why I kept it on a single page only, on a single screen. So that's all for today. See you in the next video with more and more of this type of questions. Bye.